For part 2, a student made the following 2 suggestions as to why the volume of gas collected was less than expected. So here we're looking at errors in essence. Explain why each of these suggestions is not correct. So some of the magnesium carbonate was not reacted. We calculated earlier that we're adding 0.01 moles of magnesium carbonate. We're adding an excess of magnesium carbonate. If we're adding an excess of magnesium carbonate, we're already adding more than we need. If we're adding more than we need, we are going to have some that is unreacted, and therefore suggesting that some of the magnesium carbonate has not reacted is not going to have an impact on the volume of gas produced. Number 2, some of the carbon dioxide is still in the delivery tube. We would expect some of the carbon dioxide to remain in the delivery tube. That's not going to impact our results, however, because an equal volume of air would have been displaced from that delivery tube. So the actual volume of gas that we have in the measuring cylinder will be the volume of gas that has been emitted by the reaction. Granted, it will not all be CO2 because the first part of the gas that is evolved effectively from the tube is going to be the air that is already present in there. A student modified the apparatus and collected the gas in a syringe rather than over water. The reason that we would have a closer value to our expected value is because we have a direct transfer from the apparatus where we are producing the gas to the apparatus that is collecting the gas. We don't have any medium, and therefore there is no opportunity for the CO2 to be dissolved or to disappear. In the first apparatus, we do have an opportunity for the CO2 to dissolve because gases will dissolve in water. The next question is introducing another set of apparatus. Here we've got that gas syringe that we just talked about, and we've got a tap funnel. So a funnel that's introduced, it's not open, it has a tap that is open and released. When this experiment was carried out, the volume of gas collected in the syringe was greater than 120. Now we know that that's not possible in terms of gas evolved. The reason that we might have more gas appearing in the gas syringe is because gas from here is going to be displaced when this tap is opened and the liquid is allowed to come in, and then the tap is turned off. So if we're adding liquid from here into here, that is obviously going to displace a volume of gas, and the only possible place that gas has got to go is into this gas syringe here. So if we were to introduce 50 centimetres cubed of sulfuric acid, then we would displace 50 centimetres cubed volume of gas. So that's the reason why we would have more gas than we would expect to produce. The expected volume, as I said, was 120 from earlier, and if we are introducing 50 centimetres cubed of acid, then we would look to be producing in the region of 170 centimetres cubed in total in the gas syringe. Final question. The experiment was repeated using 50 centimetres cubed of hydrochloric acid instead of sulfuric. The balanced equation for this, because we're producing MgCl2, remembering that it's 2 Cl's because that's Cl minus and Cl minus to accommodate the Mg2 plus because it's in group 2, means that you then have to balance your equation with a 2 here for your HCl. This affects the stoichiometry of the equation. It's now a 2 to 1 rather than a 1 to 1, which becomes important in the next part of the question. What effect, if any, would using this amount of HCl instead of H2SO4 have on the volume of CO2 collected? Now, since the acid was limiting at 0.5 moles, and since we still have 0.5 moles just of a different acid, we can effectively say that the acid is still limiting. If it's still limiting, that means that the volume of CO2 is still going to be dependent upon the acid that we're using. There is a direct relationship between the volume of CO2 and the acid. Now, since the stoichiometry has changed and it is now a 2 to 1 ratio rather than a 1 to 1 ratio, we would expect the amount of CO2 to be produced to be half the quantity that we had earlier with the sulfuric acid. So because here it's a 2 to 1 ratio, for every 1 mole of HCl we would produce half of that quantity, 0.5 moles of CO2. We would expect half the amount of moles, and therefore we would expect half the amount of volume of CO2 to be produced if we were using hydrochloric acid as opposed to sulfuric acid.